National Electrical Code Section 15G specifically states that the number of overcurrent devices is limited. When 3 or more overcurrent devices are installed at any location, a supplementary bonding jumper is required to be installed. There is no rule that says additional fasteners are required. Understanding the requirements for overcurrent device installations is crucial for electrical safety and code compliance. The presence of 3 or more overcurrent devices necessitates a supplementary bonding jumper, which enhances the grounding path and minimizes potential voltage differences between conductive parts. This supplementary bonding jumper ensures that fault currents can effectively flow back to the source, facilitating the operation of overcurrent protective devices such as circuit breakers or fuses. The primary function of the supplementary bonding jumper is to provide an additional low impedance path for fault current. This is particularly important in scenarios where multiple overcurrent devices are present, as the combined load and potential fault current can be substantial. By providing a robust grounding connection, the bonding jumper helps to maintain a stable and safe electrical system. Although Section 15G does not mandate additional fasteners, it is essential to ensure that all electrical connections are mechanically secure and electrically sound. Proper tightening of connections and the use of appropriate hardware are critical to prevent loose connections, which can lead to overheating, arcing, and potentially hazardous conditions. While the code does not explicitly call for more fasteners, adherence to best practices and manufacturers' recommendations is advisable. These practices may include the use of additional support or securing methods to ensure the long-term reliability and safety of the installation. In situations where vibration or physical stress is anticipated, additional fasteners or support structures may be necessary to maintain the integrity of the electrical connections. When installing a supplementary bonding jumper, it is essential to follow the manufacturer's instructions and adhere to relevant code requirements. The size of the bonding jumper must be adequate for the anticipated fault current, and the connection points must be properly cleaned and prepared to ensure a low resistance connection. The bonding jumper should be installed in a manner that minimizes the possibility of damage or accidental disconnection. Regular inspections of electrical installations are essential to identify and address any potential issues before they escalate into safety hazards. During these inspections, it is important to verify the integrity of all connections, including those associated with overcurrent devices and bonding jumpers. Any signs of corrosion, looseness, or damage should be promptly addressed to maintain the safety and reliability of the electrical system. In addition to code requirements, manufacturers of electrical equipment often provide specific recommendations for installation and maintenance. These recommendations should be carefully followed to ensure the proper functioning and longevity of the equipment. Manufacturers' instructions may include guidelines on tightening torques, connection methods, and environmental considerations. Failure to adhere to these recommendations could void the warranty or compromise the safety of the installation. In summary, while Section 15G of the National Electrical Code focuses on the requirement for a supplementary bonding jumper when 3 or more overcurrent devices are installed, it does not explicitly require additional fasteners. However, ensuring mechanically secure and electrically sound connections through best practices and manufacturer recommendations is crucial for overall electrical safety and reliability. Regular inspections and adherence to relevant codes and standards are essential for maintaining a safe and compliant electrical installation. The absence of a specific requirement for additional fasteners in Section 15G does not diminish the importance of proper installation techniques. Electrical connections must be capable of withstanding the forces they will be subjected to during normal operation and potential fault conditions. The use of appropriate hardware, proper tightening, and consideration of environmental factors are all critical aspects of ensuring a safe and reliable electrical system. Furthermore, local amendments to the National Electrical Code may impose additional requirements or restrictions. It is essential to consult with local authorities and qualified electrical inspectors to ensure compliance with all applicable regulations. Local codes may address specific concerns or conditions that are unique to a particular region or jurisdiction. Staying informed about these local requirements is crucial for avoiding costly violations and ensuring the safety of electrical installations. The concept of a supplementary bonding jumper is rooted in the principles of electrical safety and grounding. A properly installed grounding system provides a low impedance path for fault current, which helps to minimize the risk of electric shock and equipment damage. The supplementary bonding jumper enhances this grounding system by providing an additional connection between conductive parts, reducing the potential for voltage differences and facilitating the operation of overcurrent protective devices. In addition to its role in fault current protection, a well-designed grounding system can also help to reduce electromagnetic interference and improve the overall performance of electrical equipment. By minimizing noise and voltage fluctuations, a stable grounding system can contribute to the reliable operation of sensitive electronic devices. The selection of appropriate overcurrent protective devices is another critical aspect of electrical safety. Circuit breakers and fuses are designed to interrupt the flow of current when it exceeds a predetermined level, protecting circuits and equipment from damage. The proper sizing and selection of overcurrent devices is essential to ensure that they will effectively protect the circuit without causing nuisance tripping. Overcurrent devices should be chosen based on the ampacity of the conductors they are protecting, as well as the specific requirements of the equipment being served. It is important to consult with qualified electrical engineers and manufacturers to ensure that the overcurrent devices are appropriate for the application. Regular testing and maintenance of overcurrent devices are also important to ensure their continued reliability. Circuit breakers should be periodically tested to verify that they will trip within the specified time and current limits. Fuses should be inspected for signs of damage or deterioration and replaced as necessary. Proper maintenance of overcurrent devices can help to prevent costly equipment failures and ensure the safety of electrical systems. The National Electrical Code provides comprehensive guidance on the installation, sizing, and protection of electrical conductors. The code specifies the allowable ampacity of various conductor sizes and types, based on factors such as insulation temperature rating, ambient temperature, and the number of conductors in a race wire or cable. Adhering to these code requirements is essential to prevent overheating and potential fire hazards. In addition to ampacity requirements, the code also addresses the proper methods for splicing and terminating conductors. Proper splicing and termination techniques are essential to ensure reliable electrical connections and minimize the risk of loose connections or insulation failures. The code specifies the types of connectors and termination methods that are permitted for various conductor types and sizes. Proper installation of electrical equipment also involves careful consideration of environmental factors. Equipment that is exposed to moisture, dust, or corrosive substances must be appropriately rated and protected. Enclosures, fittings, and other components must be selected to withstand the specific environmental conditions in which they will be installed. Failure to consider environmental factors can lead to premature equipment failure and potential safety hazards. Electrical safety training is essential for all personnel who work with or around electrical equipment. Training should cover topics such as electrical hazards, safe work practices, lockout/tagout procedures, and the proper use of personal protective equipment. Regular refresher training is also important to ensure that personnel stay up to date on the latest safety practices. A comprehensive electrical safety program can help to prevent accidents, injuries, and fatalities. In addition to formal training, it is also important to promote a culture of safety within the workplace. Employees should be encouraged to report any potential hazards or unsafe conditions, and management should take prompt action to address these concerns. A strong safety culture can help to create a safer and more productive work environment. The use of personal protective equipment, or PPE, is another critical aspect of electrical safety. PPE includes items such as gloves, safety glasses, hard hats, and arc-rated clothing. The type of PPE required will depend on the specific tasks being performed and the potential hazards present. It is important to inspect PPE regularly for signs of damage or wear and replace it as necessary. The proper use of PPE can significantly reduce the risk of electrical injuries. Lockout/tagout procedures are used to prevent the accidental energization of equipment during maintenance or repair work. These procedures involve disconnecting the equipment from its power source and applying a lock and tag to the disconnect switch. The lock and tag serve as a warning that the equipment is being worked on and should not be energized. Lockout/tagout procedures are essential for preventing electrical accidents during maintenance activities. Arc flash is a dangerous phenomenon that can occur when electrical equipment fails or is inadvertently short-circuited. Arc flash events can generate intense heat, pressure waves, and toxic gases, causing serious burns and other injuries. Arc-rated clothing is designed to protect workers from the thermal effects of arc flash. Arc-rated clothing is made from special fabrics that are resistant to heat and flames. The level of protection provided by arc-rated clothing is measured in calories per square centimeter. The higher the calorie rating, the greater the protection. Regular inspections of electrical systems are essential to identify and address any potential problems before they lead to failures or accidents. Inspection should be performed by qualified personnel who are familiar with the equipment and the applicable codes and standards. Inspections should include visual checks for signs of damage or deterioration, as well as electrical tests to verify the proper functioning of the equipment. Thermography is a non-destructive testing technique that can be used to detect hotspots in electrical equipment. Hotspots are areas of excessive heat that can indicate loose connections, overloaded circuits, or other problems. Thermography involves using an infrared camera to scan electrical equipment and identify areas where the temperature is abnormally high. The results of the thermographic survey can be used to prioritize maintenance activities and prevent equipment failures. Power quality is a measure of the stability and reliability of electrical power. Poor power quality can lead to equipment malfunctions, premature equipment failure, and increased energy costs. Power quality problems can include voltage sags, voltage swells, harmonics, and transients. Power quality monitoring equipment can be used to identify and diagnose power quality problems. The data collected by the monitoring equipment can be used to develop strategies for improving power quality and preventing equipment problems. Energy efficiency is an important consideration for all electrical systems. Energy-efficient equipment and practices can help to reduce energy consumption, lower energy costs, and minimize environmental impact. Energy-efficient lighting, motors, and transformers can significantly reduce energy consumption. Proper maintenance and operation of electrical equipment can also improve energy efficiency. The National Electrical Code is updated every 3 years to reflect changes in technology and best practices. It is important to stay up to date on the latest code requirements to ensure that electrical installations are safe and compliant. The code is available for purchase from various organizations, and many jurisdictions offer training courses on the code. Consulting with qualified electrical engineers and contractors is essential for ensuring that electrical systems are properly designed, installed, and maintained. Electrical engineers can provide expert advice on system design, equipment selection, and code compliance. Electrical contractors can perform the installation work and ensure that it is done safely and correctly. Regular communication and collaboration with electrical professionals can help to prevent problems and ensure the long-term reliability of electrical systems. In California, specific regulations and codes may apply in addition to the National Electrical Code. It is crucial to consult local authorities and qualified inspectors to ensure compliance with all applicable requirements. The California Electrical Code incorporates the National Electrical Code with some state-specific amendments. These amendments may address unique environmental conditions or specific concerns within the state. Staying informed about these local regulations is essential for avoiding violations and ensuring the safety of electrical installations in California. Continuous learning and professional development are vital for staying current with the latest advancements and best practices in the electrical field. Attending workshops, seminars, and training courses can enhance knowledge and skills, leading to improved performance and safety. Certifications and licenses demonstrate competency and commitment to professionalism, further enhancing credibility and career opportunities. By investing in ongoing education, electrical professionals can ensure they are equipped to handle the challenges of a constantly evolving industry.